Good afternoon, and welcome to the September webinar, the phone seminar series on green chemistry, brought to you by the Great Lakes Green Chemistry Network and the Michigan Green Chemistry Clearinghouse. My name is Clinton Boyd, and I am the Technical Director of the Michigan Green Chemistry Clearinghouse. Today, I have the privilege of standing in as the host for today's webinar on behalf of Lynn Katz-Jerry, the Executive Director of the Great Lakes Green Chemistry Network, who is unable to attend today. The phone seminar series on green chemistry is dedicated to providing diverse perspectives on green chemistry from a broad audience in the form of monthly webinars. Today, we have the honor of hearing from our presenter, Brenda Platt. It is now my pleasure to introduce today's speaker, Brenda Platt. Brenda is the co-director of the Nonprofit Institute for Local Self-Reliance, based in Washington, D.C. Brenda has worked for 26 years on waste reduction, recycling, and composting issues. I've had the privilege of working with Brenda on these issues in the past and can confirm that she is very enthusiastic and very passionate about this topic. Brenda is also the co-chair of the Sustainable Biomaterials Collaborative, the subject of the presentation today. Welcome, Brenda, and thank you for agreeing to do this presentation for us today. The floor is now yours.
Thank you, Clinton, and it's my pleasure to participate on the webinar today. This is some of the things this is an overview of what I'll be covering. So I'm going to, in the few minutes I have with you all today, I'm going to just say a word about what the Sustainable Biomaterials Collaborative is. And I'm going to talk about the guidelines for sustainable biomaterials that we've been developing over a number of years. What makes a biomaterial considered sustainable or green. And some of the issues that we often hear when we hear about biomaterials, that they're bio-based, they're compostable, they're biodegradable, what's the difference? So sometimes it's very helpful if we all get on the same page with some of these basic definitions, and so I'll just touch on that. And one of the main points I want to leave everybody with is the point that bio-based content alone, or compostability alone, is that those attributes alone are not really a measure of sustainability. Sustainability is more broadly defined. And there are really challenges ahead in moving towards sustainable biomaterials. I think that they can be overcome, but there's some challenges, so I'm going to identify some of those. One of the products categories that the Sustainable Biomaterials Collaborative has focused on initially is bio-based compostable food serviceware, and largely because they're already introduced in the marketplace, really from coast to coast in some regions of the country. If you're in Seattle and San Francisco, you may see those more. So we've been working, developing kind of purchasing specs and other market-based tools on bio-based food serviceware. So I'll talk a little bit about those, and then for the other market-based tools, a unique market-based tool we've been working with the Institute for Agriculture and Trade Policy called Working Landscape Certificate. So I'll talk about that. So these are the things I'll be covering today. So let me just dive in. The Sustainable Biomaterials Collaborative is a network of organizations working together to spur the introduction and use of biomaterials that are sustainable from cradle to cradle. And how we're doing that is we're developing these guidelines I talked about, we're engaging markets, and we're also promoting some policy initiatives. These are some of the groups that were part of the collaborative, helped us get founded, which we've been around now, I think, for about 5 years. The steering committee groups, Clean Production Action, Institute for Agriculture and Trade Policy that I mentioned, my organization, and Lowell Center for Sustainable Production have been the main groups kind of steering the work over the last few years. But we would, welcome other groups joining the network and participating. One of the things that we've been looking at in terms of defining sustainability of bio-based materials is over its life cycle. So not just looking at the products itself and end of life, but what are they made from? Are the feedstocks grown sustainably? Then when in the manufacturing stage, are you adding harmful additives or other harmful chemicals? So just because it's bio-based doesn't mean it can't have harmful additives added to it to enhance its performance characteristics, just like conventional fossil fuel-based plastics. And then end of life is something I'll just mention that is my particular expertise in the 26 years I've been at the Institute for Local Self-Reliance, most of my work has focused on end-of-life issues. And I'm very much now engaged in composting and compostable products, so trying to encourage and increase food waste diversion in particular. So that's where my expertise is. We developed back 4 years ago these guidelines for sustainable bioplastics, and I'm just going to run through briefly some of the key principles that are included in there. Don't worry, I'm not going to read this, but you can you'll have it, as Clint mentioned, in the PDF. But none of this is probably surprising. We should be designing and using products that are reusable, recyclable, or compostable. In terms of sustainable feedstocks, one of our key interests is using agricultural feedstocks that are not generated from genetically modified organisms. You may in particular be interested that key principles are using chemicals that meet the 12 principles of green chemistry. Engineered nanomaterials is a particular issue because a lot of the R&D that's taking place to enhance the performance characteristics of bio-based materials is adding engineered nano products to enhance gas barrier properties or the temperature that these products could withstand. So is that an issue? Should we be adding engineered nanomaterials to bio-based products, calling them green or sustainable if we don't know the impact of adding those engineered nanomaterials if we haven't tested for the public health effects across their life cycle? So these are just some key principles, and those are included in the guidelines. The 3 stages in particular that we have been really looking at is the sourcing of the feedstock. So we're not just interested in biomaterials that are sourced from renewable crops or trees. We want feedstocks to be sustainably grown and harvested. So these are some of the considerations, biological diversity, are workers protected? I mentioned, avoiding genetically modified organisms. At the manufacturing stage, we want the manufacturers to support that the feedstocks are sustainably grown. Avoiding problematic blends and additives is also important. And it's at the manufacturing design stage that you actually have the most control over whether the product could be reusable, recyclable, or compostable. So that's at the manufacturing stage, and then at the end of life, as I mentioned, products should be designed to actually be recovered at the end of their intended use. And one of the key, some of the key issues that are coming up for bio-based materials in particular is recyclability, is compostability, and because plastics, as many of you may know, are such a big growing problem in waterways and in our oceans, another consideration, is are bio-based materials coming on the market? Can they biodegrade in aquatic systems? And then product labeling is like the perennial problem with a lot of these products, and I'll touch on that just a little bit. And then, is there a place, for these products to go if we do, if businesses are paying a premium to use them, and then they're labeled as compostable, is there actually facilities that can take this? And that's a big issue as well, and one that I am working on. So the guidelines lay out kind of a steps to best practices, and just to give you, this is just one example, that is listed in the guidelines, but for instance, avoid plastics with persistent organic pollutants that are manufactured with high hazardous chemicals. And so polyvinyl chloride, polystyrene, polycarbonate, polyurethane, those are the ones to avoid. What's better would be blending with more preferable plastics like polyethylene, polypropylene. Improving would be bio-based resins that are compostable. But one thing, as I'll share in a few minutes, is just because it's compostable doesn't mean it's made from bio-based materials. So what would even be better is that the materials have an end-of-life recovery scenario but are also bio-based. And then we lay out kind of the best is, perhaps a pure bioplastic that is fully compostable and recyclable. So the guidelines kind of look at how can we continuously improve. They're available on our website. We have the guidelines and, online and lots of resources, so I invite you to check out our website when you get a chance. One thing I can tell you in the few years, the number of years I've been going to industry conferences and looking at this, is that it is amazing how fast this industry is progressing. There are more and more products available, more resins, their performance is improving, growth is expected. Programs such as the federal bio-preferred purchasing program are opening up new markets. There are new standards coming in, that are becoming more widely accepted, and standards around how do you measure bio-based content, or how do you measure biodegradability or compostability. Price competitiveness is improving and demand is increasing. So I think the market is growing, and bio-based products are really here to stay. And one of the main work that the Sustainable Biomaterials Collaborative is really looking at is how can we really help encourage the introduction of products and resins to the marketplace that are sustainable across their life cycle and not just based on a few single attributes. One of the for one single attribute, compostability, and this is just an example of not only is there a standard available to measure compostability, but there are third-party certifiers available. In North America, it's the Biodegradable Products Institute, and just this week they actually announced their searchable database, so you can identify which products do meet their third-party certification. And I would say probably about a year ago they had under 500 certified products, and now it's above 3,000, and almost 150 global companies. One thing I'll just note, which I have here, is that just because it's certified as compostable, again, does not mean it has to have any bio-based material content. So compostability and where the feedstocks come from, what it's made out of, they're not related. You can have some of the certified resins are 100% fossil fuel-based resins. And this gives an example of some of the products that are certified. And I think one thing that's really interesting about this list is that you have some big German, big companies like BASF, which is a, big German chemical company. And in fact, they're an example of a company that's making a compostable resin that's made from 100% fossil fuel-based feedstocks, to companies like Vertera that are making dinnerware literally from fallen leaves. So you've got big and small and medium-sized, and it's growing, as I said. But again, just because it's bio-based or compostable doesn't make it sustainable. And these are some of the claims that you'll see, environmentally neutral, easy on the environment, return to nature without a trace. But, how can we verify these claims, and what do they really mean? Are these products truly green? And I have some examples here in the photos, like the plate on the bottom right says earth-friendly plate, but I don't know if you noticed, is that a reusable, durable plate? No, it's a single-use, plate, and maybe it's made from bio-based materials, but it was not certified as compostable. Here's another example where it's a single-use cup labeled as ultra green. I know that's hard to read. It's not a very good high-resolution photo, but we're not just green. We're ultra green, and I submit to you that you can't have a single use, a product made to be used once and, considered ultra green. That's not ultra green in my book. And when we look at products, there is a hierarchy. One of the things that the Sustainable Biomaterials Collaborative does promote, even on the food service work we've done, is, where you can use reusable products, wash them, and if you're going to use single-use products, then make sure that, they are third-party certified compostable, and then also look at some of the other attributes that you can be promoting to make them even greener. Some of the things besides bio-based content and recyclability that I think are really key is the additives and blends I alluded to. I'm going to talk a little bit about that. Performance really varies on bioproducts. Even on biodegradability, some products might meet the ASTM standard for compostability, but they may not meet any standards for home compostability. Or will they biodegrade in a compost facility in addition to the marine environment? Not necessarily. Sometimes the feedstocks are grown in the U.S. for U.S. products for U.S. markets. Sometimes the feedstocks are grown in China and imported here. How does that make a difference? So these are just some of the considerations about bioproducts and whether they should be considered sustainable. Now, bio-based content, I think, is something that we would like to see maximized. Some of you may be familiar with the U.S. Department of Agriculture's Bio-Preferred Purchasing Program, and the USDA's program now has another element which they're doing labeling of products. So a product company could have its products submitted and tested, and they will carry this label, USDA certified as a bio-based product. It'll have the bio-based content on there for the product itself, and it will also have the bio-based content of the packaging that the product comes in, which we think is very good. And this bio-based content does not measure the overall bio-based content of the overall product. It just does new carbon, if you will, to old carbon. So it will be the bio-based content as it relates to the fossil fuel-based content. But if there's minerals in there, you know, it does not take that into consideration. So that's just really important. But one of the good things about this test is that anybody could take a product and have it tested because of this radiocarbon analysis that's done. You know, it's something that's measurable. Products can be compared. So, you know, there's not so many gray areas with doing a test like this, and that's one of the things that I think makes this program, you know, very robust. But one of the things that the USDA has done is they're kind of casting a wide net and encouraging a wide range of products to be in their purchasing portfolio, if you will. And we at the Sustainable Biomaterials Collaborative have been trying to raise the bar a little higher, that to be considered a bio-based product, you know, maybe you should be having at least half of your bio-based content of your product, you know, meet 50% or higher. We did a study a few years ago looking at just compostable bags. And these are compostable plastic bags that would be used, for instance, to collect food scraps that would be destined for a composting facility. A variety of sizes. And just so you can see, just to give you an example, there's some brands, what it's made out of, and then the bio-based content using that ASTM standard. And it really does vary, I mean, all the way from Nature Text bag, 1% bio-based content, to the EcoSac and the bio bag, kind of above 46, 47%. So, you know, when you're saying like bags that are labeled compostable, you may say, oh, they're made from corn or they're all bio-based. Not true. This indicates, at least when we did this data a few years ago, that, you know, most of the bags were coming from fossil fuel-based resins. This is increasing. A lot of these, like these bags, I think if they would be tested today, they would all be higher. So it's really been developing very, very quickly. GMO we looked at, we asked where the feedstock's coming from. A number of them do not, you know, are GMO-free, but a number of them are not. We listed here what are the certifications. Now, BPI is the Biodegradable Products Institute. I mentioned they're kind of serve North America. DIN-CERCO is Europe, and so is Vinsat. So, you know, this kind of gives you an idea that most of them are certified as compostable, but then what about home and backyard? Well, the OK Compost mark is the Vinsat system, and it's not really in place in the U.S. does not have a standard for compostability in the backyard. So, you know, you really have to, as we like to say, is ask for the data. So trust, but I think as Steve Mojo says at the Biodegradable Products Institute, trust but verify. There is definitely, you know, labeling we'll probably come back to several times, but there are some issues with labeling. This is the Coke bottle, the Dasani water bottle that's introduced a number of years ago, and it's probably the most widely used bio-based product in the marketplace. The marketing that Coke does, as you can see here, it's up to 30% made from plants, but that's not based on that ASTM bio-based standard I mentioned. Using that, it's closer to 20%. So there's a little bit of confusion in the marketplace and what does it mean, and there's a lack of consistency among the brand owners and the products for how they're going to be labeling these products and marketing them. USDA acknowledges that bio-based content is not necessarily, an indicator that it's environmentally better. And this is just some of the questions and answers from their frequently asked questions. But are they safer for me and my family? Well, not necessarily. Are they better for the environment? Can be. Does a higher percentage of bio-based content mean a product is better? They say not necessarily. I will emphasize, though, that the fact that you do have higher bio-based content, we strongly believe is much better, because there is a strong case to be made for renewable feedstocks in terms of carbon and climate change. So that, but it's not alone. Again, not alone. It's not a measure of sustainability alone. I put in red here, I thought what was interesting, the label is not meant to impart environmental attributes to bio-based products. So even USDA acknowledges that bio-based alone is not necessarily better. And this is just an interesting example, because this is a product not made in Asia, none in the United States, and it carries the bio-based label, and it's 50% bio-based content. And this company was actually at the exhibit hall of the U.S. Composting Council conference, but it's not compostable. So this is an example of how the label is very misleading. I mean, folks, planners and community leaders who are running recycling and composting programs are very concerned about labels like this, because the average person who sees a label that says bio-based, and let's say you're lucky enough to be in a community that has a green bin that you can actually put your compostable plates in, or pizza boxes and the like, this implies that could go in there, when in fact it's not certified. So bio-based does not mean compostable, and this is just an interesting example of that. I actually touched on this, so I'm going to skip, not go through this again. But again, bio-based does not mean it's biodegradable. And the Coke bottle is a perfect example. That Coke bottle, and I didn't say it before, but that's actually a PET bottle, where the polyethylene part is derived from sugarcane, and the terephthalate part is not still from fossil fuels. So they haven't kind of cracked the whole code to make that 100% bio-based product, although that's Coke's goal. But this is a PET bottle, and one of the benefits of it being a PET bottle, even if it has only 20% bio-based content, is it's recyclable. It can go in any curbside bin in the country and go into the existing recycling infrastructure and be recycled, because it's PET. It's just now partially derived from new carbon versus old carbon. A lot of false claims. I'm going to give you some more examples. And one of the things I find interesting is that this is not new. This is a cover of Environmental Action, which doesn't exist anymore, from 1989, when we first had, quote, degradable plastics introduced made from cornstarch that basically degraded into smaller pieces and created a lot of problems, which has actually led to the good standards and the third-party certification that we have today. So we've come a long way since 1989. Here's just some examples, I think, of some, I don't know, fuzzy claims. Biocompostable cutlery. Not quite sure what that means. There are, this is a bottle, and it's not alone. There are a number of bottles like this and products like this where it's advertised as earth-friendly packaging solutions, and that are, quote, recyclable, and they can biodegrade in a landfill. Well, I will submit to you that being biodegradable in the landfill is not an environmental attribute. We want to stop materials from biodegrading in landfills because of the methane emissions from landfills. And I will also tell you that no recyclers want this bottle. The oxodegradables is another kind of conventional plastics that have transition metal added to them that helps them break down into smaller pieces. I call them oxofragmentables. And you can see here in this bag on the left that it says biodegradable bag. Well, these kind of conventional plastics added with a metal meet no ASTM standard for biodegradation. And all of the standards, by the way, for biodegradability, you have to meet those standards, like a biodegradability in a compost facility, there's a time that it has to biodegrade. And it does mean that the material is food for microorganisms. So it's not just fragmenting into smaller pieces. So biodegradation in the soil, there's a time frame for that. Biodegradation in anaerobic digester, to meet that standard, it has to happen within a certain time frame. These types of plastics do not meet any ASTM standard for biodegradation. This one I love, biodegradable PVC, another false claim. To be truly compostable, it has to undergo degradation and at a rate consistent with other known compostable materials like leaves. And so there are actually, I won't go into the standard itself, but there are 3 parts of the standard. And one of the parts is that the actual compost has to be able to, plants have to be able to germinate and actually grow. So there's kind of which might be of interesting to you all, because there's basically a toxicity piece of the puzzle here. So it's not only that it disintegrates and biodegrades, but we have to make sure that the final product is not toxic to the plants that will then grow in it. Some of the other challenges with bio-based products, in addition to kind of the labeling, and I mentioned the nanomaterials earlier, and the need to develop, adequate composting programs, especially for some of these products, is, these are just some of the key issues that are facing, I think, the bio-based products in order to be considered sustainable. And some of these are being addressed, so that's the good news. Just talk a little bit about recycling, because I've been talking about composting more, and some of the resins like NGO, NatureWorks NGO resin, which is the corn-based polylactic acid, which is shown here, that there's a bottle by Noble Juice made out of PLA, and they've taken this off now, but if you can see in this picture right here, it had the recycling symbol. But there's really no curbside program. There's no curbside program that wants these type of polylactic acid bottles, PLA bottles. Now, they're working very well in some closed venues. In the bottom left here, I show Brussels, a festival in Brussels, where they're using the clear cups and they're collecting them because it's much easier to do in a closed venue, and then it's being recycled. And one of the benefits of PLA is that it's, 1, commercially compostable, 2, can be mechanically recycled as well as chemically rehydrolyzed back to lactic acid and be recycled. And then it has actually wider markets if it's back to lactic acid. And the NatureWorks and others have been supporting a number of pilot recycling programs, primarily in California. And the good news is that it can be sorted, but there are costs associated with that. And I think that's just one of the obstacles. And this slide was produced by my friends in Minneapolis, Eureka Recycling, who looked into how can we sort and identify, bio-based bottles from other bottles. So, if you look at this, one of these bottles is a bio-based bottle. Can you tell which one it is? Well, there's Waldo right there. And they looked at what the cost was. They realized that optical sorting was technically feasible and that resin detection works and it could be identified. But because it's like almost a catch-22 situation, because bio-based products is such a small portion of the waste stream, you cannot justify putting in the additional optical sorters or the conveyors or the storage hoppers to do that. I mean, they estimated an optical sorter cost between $125,000 to $200,000 per unit, and by the time you add the conveyors and other hoppers you need, you're looking at $350,000. And one of the things that I like to promote is not just big centralized facilities, but locally based, smaller recycling and composting facilities. And, those smaller facilities are going to be increasingly at a competitive disadvantage if they're going to be expected to sort, more and more different types of plastics or biopolymers. I will say, though, that bio-based resins are not alone when it comes to plastics being recycled. This is an issue really facing the plastics industry, is how to sort out materials. And, you may know just from your own communities that the plastics that have the highest recycling rates are the soda bottles and the kind of more the shampoo bottles, the PET and HDP number 1 and 2, and all the other resins. There's so little recycling going on. So again, it's not an issue just for bio-based resins, but where I think it's kind of, raises for me that bio-based companies need to look at this is they're positioning their products as green and sustainable and good for the environment. And so if you're going to be selling us on that, then you have an extra onus on you to make sure that there is an end-of-life recovery. All right, so I mentioned that we're focusing, done a lot on food serviceware. One of the things that we looked at is developing very specific specifications. We're calling them for short biospecs. And our first product category we looked at was food serviceware. And I'm going to just run you through some of the very specific criteria we came up. Not in big detail. I'm going to give you an overview. And again, we came up with criteria for each life cycle stage. So the production of the biomass, kind of in the field, then the manufacturing, and then the end of life. So this is just kind of give you a flavor. We came up with 3 recognition levels. I mean, this is kind of similar to other programs that you may hear about: bronze, silver, gold. If a product meets bronze, you're kind of baseline in there. Silver, even better. Gold, kind of more aspirational. So on the bio-based carbon content, we want to see that for non-cutlery, most of the food serviceware, that in order even to be considered bronze level, 90% or better bio-based content. Cutlery, when we, and by the way, we evaluated maybe 40 to 50 products made by 24 manufacturers in developing what these levels would be and where the manufacturers were. Cutlery, there weren't enough products in the marketplace that were above 90%, so we set a lower bar for cutlery. But to be gold, you have to meet 99% or better. Genetically modified feedstocks, to be bronze, you can do an offset. And I'm going to talk about that. One of our market-based tools is a working landscape certificate program, which is actually an offset. And that works sort of like if you, on your electric bill, if you have an option to do wind energy, and you pay a little premium, to support the wind energy system, but that doesn't mean that the electricity that's delivered to your house is actually from a wind farm. But by paying that premium, you're promoting the development and infrastructure of wind energy throughout. And this kind of works the same way that if you're a company and you want to support sustainably grown corn, you figure out how much, and you're using polylactic acid, PLA, you figure out how much corn would need to be sustainably grown and how much PLA that would produce. And then, you pay a premium to a farmer to switch from not conventionally grown corn to sustainably grown corn, and then that's an offset. So you're, increasing sustainable agriculture, but it doesn't mean that the PLA that you're actually using in your product was from that farm. And actually, something could be said that if a farmer is growing corn sustainably, maybe that corn should go into the food system and not into, packaging and products. The biospecs, which are available on our website, have very detailed information on them. This is just an example where we say for bronze, genetically modified crops are allowed in the field with offsets. We go into what the intent, why we set that, and then we have the verification requirements. And in this case, I mentioned working landscape certificates for corn is available. NatureWorks also has an offset program, and so you can go and click and get more information. Stonyfield Farms is the first major buyer of the working landscape certificates, and they did it for these multi-pack yogurt cups. And one result is that they are now supporting 500 new acres have kind of moved over to sustainable corn production as a result. And one of the things that was interesting in their shift is that they were using polystyrene yogurt cups before, and they actually got process efficiencies from switching over to PLA. So in the end, even though they paid a premium for the working landscape certificates, they didn't end up having their costs go up. On the manufacturing side, these are some examples of the criteria. Bronze, the first one listed, I'll just talk about no organohalogens. One of the things we found in our survey is that some of the paper-based or bagasse-based plates were using organofluorines as a grease barrier, and so that led us to kind of really call that out as a bronze level. And then, if you're gold, you want no chemicals of high concern. Silver, no chlorine or chlorine compounds. And I'll just give you an example, from the biospecs. For the bronze level, you cannot intentionally add or use as a coating organohalogens, has the intent. And then in this case, to verify it, it's using XRF technology to identify, any heavy metals or organohalogens. These are just some more examples of the intent, how to verify. And again, you can see some of these are very aspirational. The gold option, all additives must be tested for hazards to human health and the environment. And then some of these are very challenging to verify, and Clinton could probably weigh in on this because he worked with us on some of these developing these guidelines for how to meet and assess conformance to these criteria. On the end of life, third-party certification for commercially compostability is very important. If you want to be considered silver, being compostable in your backyard. Gold is biodegradability in marine or freshwater environments. And then again, some detail about what the criteria is, the intent of the goal, and how it could be verified. And I just have a few more slides, because then we want to leave some time for questions and answers. But I'll just we've taken those purchasing specs, the biospecs, and we've developed purchasing specifications that big purchasers could use. And in the purchase, and this again is available on our website, and there's different points for meeting going beyond baseline criteria. So that if you want more detail, it's on our website. Happy to share it. I want to just touch on some of the activities we've been doing the last year or so. We have partnered with the Green Purchasing Institute, which is also bought the Responsible Purchasing Network, and we've been beta testing the purchasing specs with some buyers. We've developed a guide for manufacturers to voluntarily assess conformance to our guide. This is something that Clinton had helped us with a few years ago. We were pursuing partnership with a third-party certifier for the biospecs for food service ware. I was working with Elemental Impact with the Atlanta Airport. They have a new 10-year provision that we convinced them to spec only compostable food service ware. And this is one of the, maybe the biggest airport in the world. So, and we've been rolling out what that means. We've been documenting some of the venues using and composting bio-based ware to see how they're doing, and that's available on our website. We've been promoting policies, and I've been very much involved in my own community trying to work on polystyrene, especially styrofoam lunch trays in schools. The Responsible Purchasing Network and Practice Green Health worked on they have kind of looked at the biospecs and came up with some key questions for their members. This is the kind of the greening the healthcare sector, and There's new, these suggested environmental considerations for disposable food, where it basically includes questions that purchasers can ask suppliers about their green certifications and other environmental attributes of their products, and so that's available. We worked with the National Association of State Procurement Officials. Again, this was our work partnership with the Responsible Purchasing Network. This came out almost a year ago on purchasing options, again focused on food serviceware, but they did refer back to the biospecs, and again, although there's kind of the emphasis on the compostability, they also put in there an emphasis on high bio-based content and some other things. The state of Connecticut was one success where we worked at the state level, where we got not only compostability, but we got worked in there that they had to be free of the organofluorines, so for the grease barriers. So that was kind of a success. These are just some examples of the early adopters we've been documenting. It's available on the Institute Sustainable Plastics website, but the Georgia World Congress Center, I'm just giving you a flavor. In California, we have a University Medical Center. In Oregon, we have a big sports stadium, and in Washington, a big sports stadium. The airport, one of the things we worked on was producing kind of a fact sheet packet on what, why bio-based, why compostable, what it is, how you can meet that, and that's something we did in partnership with the Sustainable Food Court Initiative. And then this I'll just end with is just some parting thoughts, just to kind of wrap up, is that the life cycle thinking, we should define what we want. So if it's not just bio-based or renewable feedstocks, but we want green chemistry, or we want cradle to crave, or cradle to cradle, and we want feedstocks from our forest or agriculture that are sustainably grown, then we need to make those priorities and set standards and criteria to help the marketplace meet those. There's a real need on the food serviceware in particular to expand the composting infrastructure, and we're working on that, and we're looking for business support to help those policies. And I know sometimes you have to kind of repeat things over and over, but I hope it became clear, to all that bio-based is not inherently better, that we need criteria and standards to help us define, what makes a sustainable biomaterial. And these are some of the things that we're particularly been looking at, like no GMOs, and we want inherently safer chemicals, and we want to make sure there's an end-of-life scenario. So I'll end there, and the last slide I'll just leave up for you is my contact information. So back to you, Clinton.
Thank you, Brenda. That was a great presentation. It was a great summary of a journey that I'm sure our listeners will appreciate has been both long and challenging. It's very heartening to see the progress that's been made and all the successes that you've realized. It's, again, very exciting. So in this last 14 minutes of our webinar, we'll open up and begin our question and answer session. And so just to remind you that you can submit your questions in writing using the question box, which you'll find in the navigation bar on the right-hand side of your screen. We will not be opening the lines. I will read out the questions that you type in. So please note that using the raising your hand function will not work. Please just submit your questions in writing. So I do have a couple that are in, so we'll start. So the first question we have is if you could explain, Brenda, whether or not bioplastics is synonymous with the term organic. And the term organic here has been put in quote unquote.
Oh, I love that term organic, because depending on which field you're in, I have this great slide I don't have in this one where I have, the organic dry cleaner next to the organic food market. And then you have, if you're working in the waste side field like myself, organics mean food scraps and yard trimmings and grass clippings. That's what organic is. But, from a chemistry side, which I, assume this question is, bio-based, is, bio-based means renewable, made from, if it's a bio-based material, it's made from renewable feedstocks that are annually renewable, is generally the accepted, understanding of what bio-based means.
So I think I would add to that, Brenda, just I think maybe the question may have also been relating to the fact that the USDA now has a bio-preferred program, but also has the organic program. So maybe in case that was the question, maybe you could just explain the difference between those two programs.
Yes. Oh, okay. So let me add that a product that meets the USDA's bio-based, their criteria, if you're a bio-based product, has nothing to do with organic agriculture and growing materials organically. And in fact, one of the things that's interesting is that the NOPE, the national, what does it stand for? But the group that's in charge of setting the standards for what can go into organic agriculture, and compost, for instance, is one of those allowed feedstocks. It has disallowed synthetic bio-based resins from being composted and being sold, then that compost being sold to organic farmers. Now, there's a petition now that's going on, and I actually don't know the status of that right now, with the Biodegradable Products Institute to get biodegradable mulch films as allowable to go to organic farms, because there's some obvious advantages for using something that's truly biodegradable in a farm versus just conventional plastic that doesn't break down, which actually is a huge problem for farmers. So, but as of now, if you're a compost facility and you're taking in a bio-based resin like NGO, the PLA, you cannot compost that and sell that to an organic farmer. So in some areas of the country where the composters are selling into that market, they're actually having two parts of their compost facility where they keep those materials separate. And there's, one thing I'll emphasize, there are growing markets for compost. So certainly organic farmers need compost, but there are many applications for high quality compost. It's not the only market, but clearly, to be bio-based does not mean it has to be grown organically.
Okay, thank you. So the next question relates to the genetically modified organisms. I think the person asking the question is recognizing that that's quite a central theme in the bronze, silver, gold levels within the biospec. So the question relates to what is the concern with the use of GMO crops in bioplastics?
Well, one of GMO crops is the profusion of genetically modified crops on the landscape makes it difficult to directly source non-GM crops for industrial production. And what our offset program does is support non-genetically modified crop production. In North America, many of the biomass crops currently in production have been genetically modified, primarily for resistance to herbicides or insects, but I don't know what the latest figures are, but it's like 85% of all field corn planted in the U.S. is genetically modified, 90+% of the soybeans, most of the canola, have all been modified. And so genetically modified crops, I mean, there's kind of a growing body of work that says we don't really know, the full impact of GM biomass crops. The widespread use has resulted in a documented increase in the use of herbicides and the spread of herbicide-resistant plants. And there are many under-addressed and under-researched environmental, biodiversity, health concerns about the introduction, use, and dissemination of genetically modified crops. So, we're kind of helping to move the marketplace to encouraging more non-GMO, more sustainable ag. And one thing I'll say about the Working Landscape Certificate Program is that it's not for the farmers who move from conventionally grown corn to more sustainably grown corn. It's not just that their corn is from GMO-free feedstocks, but they have to meet a whole checklist of sustainable agricultural practices. So, whether it's no-till or, switching the land and doing, other crops, alternating, seasons, or conservation practices. They have to be free of atrazine, some of these other, harmful herbicides and pesticides. So it goes beyond GMO, the Working Landscape Certificate. So that's one of the benefits of doing that particular offset program.
Great, thank you. So the next question we have is simply, well, I say simply, but how do you define chemicals of high concern?
So there's in the biospecs, the chemicals of high concern is basically that manufacturers have to verify that the product is made with no chemicals that are included in this, quote, red list of chemicals listing. And this is one of the our partners in the collaborative, Clean Production Action and the Healthy Building Network have been listing the green screen for safer chemicals. So those are, those are where the list is, the red list of chemicals, and that's the gold option. For the silver, as you may have seen, it was no Proposition 65 chemicals may be used in the product, and there, product manufacturers can verify that no chemicals included in the California Proposition 65 list of chemicals.
So the next question we have, firstly, just thanking you for a great presentation, and this actually comes from one of the leaders of green chemistry education here in Michigan. And as a teacher of green chemistry to chemistry majors, a comment is made about how important understanding the difference in how terms are used is important to the conversation. So I think this is a follow-on from the discussion we had about the different meanings of organic. So the question that follows this comment is, as you're talking, as you try to communicate these success stories or meeting with your clients, do you find that this is important, that making sure that people are using the same terms when you're trying to have these conversations? And as a part of the question too is whether you feel there's value in having someone or an entity that is familiar or conversed in green chemistry being a part of your team as you meet with your clients.
Well, I think terminology is really important, and a lot of people, not only in the field. I mean, I deal with a lot of on the waste side of things, but purchasers who are buying these products, they have no idea the difference between bio-based, biodegradable, compostable. And I do think the Biodegradable Products Institute has really advanced things with their third-party certification, but it's been critical for us in the collaborative. We've had a technical advisory group. Clinton has been on that, so having chemists like himself on there helping us not only get the criteria right and how we define things within our own circles and our own stakeholders, it's been really critical. I would say then translating that to the outside world is just like another level. And, we did, in the food service where, for example, we did the biospecs and laid out the criteria, but a purchaser, we started working with purchasers and they were like, okay, we don't have the time to get the data from the companies telling us how they meet ASTM D6400 or 686X, you just give me the list, Brenda. Give me the list of what is okay to buy. And so that kind of led to partnering with the Responsible Purchasing Network to develop kind of a purchasing model for purchasers. So we are trying to translate some very challenging new concepts into what, if you're the Atlanta airport, what can you understand? And that fact sheet, that I used as an example was really an example of how we distill it down. We try to make it easy. Buy products that are listed on the Biodegradable Products Institute, for instance. Here's how things are defined. This is why we need to compost more. So, yeah, I mean, it's really important to define things, but also to simplify, to really make sure your message is heard and to reach a wider audience. But I'm really interested in hearing from anybody about how we can do that better.
Right, so we have 2 minutes left before we reach the end of the hour. So I'm going to actually take the initiative and ask the last question. But just to build on Brenda's last offer there, if you do have any other questions that you would like to pose to Brenda, or have any other comments or feedback that you'd like to provide, please email us at migreenchemistry@gmail.com, which you'll find up on the screen right now, and I'll pass those on to Brenda, get her to answer, and then we'll post the answers up on the Michigan Green Chemistry website. So to close, Brenda, one of the questions that I've been thinking about is, you've been very involved in the bioplastics world, and you've mentioned quite a few of the kind of innovative bio-based resins that have come up, ranging from bio-based polyethylene terephthalate to polylactic acid. So I have a two-part question. Are you seeing any other bio-resins that may be commercialized soon or coming on the market, that may be in development phase, that maybe will be kind of like the Eureka resin that will address all of these different concerns?
What an excellent question. The first one that comes to mind is, and I'm not sure if I'm saying the company exactly right, but Segatis. They're based in Golden Valley, Minnesota, I believe. And they've developed a new bio-based building block based on levulinic acid. They hydrolyze cellulose. I think they're doing it from corn cobs right now, but they can use other sources of cellulose. And they hydrolyze it to glucose, and then they dehydrate it to some other form, and then it's, and then they end up with levulinic acid. And one of the things, that levulinic acid shows is kind of this broad utility as a building block for all kinds of chemicals and materials. I think they're trademarked under the Javelin name, but multiple product lines include like the plasticizers and solvents and surfactants and polymers, and it's basically, a new molecule that would substitute for some of the bad plasticizers and for bisphenol A and bad plasticizers and PVC, and apparently it also could be a good solvent as a low, volatility. So, there's some really, I think, interesting bioresins that are coming on the market, and I get most excited when they're kind of new building blocks that could lead to a whole host of new chemicals and materials that don't need the additives to enhance, their performance characteristics. And then the other company that came to mind when you asked me that, it's not really a bioresin, but it's a bio-based product, and the company is called Ecovative, and I think they're outside of Albany in New York. And they've been making a substitute for styrofoam, like for packing. Like if you're shipping an office furniture and you need corners on the desk to protect it in shipping. And they're making that from in a matrix of fungi, mushrooms essentially, and then they're using agricultural waste, rice hulls and stuff. And it's a kind of a distributed manufacturing company, so it's kind of small scale and they could do it anywhere, and so I find them pretty exciting too. And their product, in terms of end of life, is marine biodegradable, and in fresh water too, and home compostable, and those things too. I don't know about the Javelin, levulinic acid in terms of end of life, but in terms of just being, it seems to me, a kind of, cleaner, healthier building block has potential. So those are the two that came to mind.
Well, thank you. Well, on that promising note, I would like to thank you again for the great presentation today, and thank you to all our listeners for attending. And with that, we'll end today's webinar, and just remind everyone we'll be back again on October 31st with a presentation from Professor Bloomberg from the University of California talking about obesogens. And thank you, everyone. Goodbye.